Hello and welcome to Ask the Expert webinar series. I'm Atul Dev and today I'm going to talk about HyperWorks for safety using HyperWorks 2022. HyperWorks safety solutions includes occupant safety, safety regulation, load case setup, pedestrian safety, barrier positioning, and safety regulation post-processing using Altair Safety Report Manager, also known as ASRM. So let's look at the global overview of these tools using HyperWorks. So let's start with occupant safety. So as you can see on this slide, there are various options available in HyperWorks for occupant safety. It starts with mechanism. It's very intuitive tool and you can create the seat mechanism automatically or you can create it manually between two bodies. But the seat mechanism offers a very simple workflow where you can position the seat to the required position and you can save the position and export the position. You can directly take the seat position to the required edge point in just one click. So that was about seat mechanism. After that it comes dummy positioning. So it's very simple process. Positioning the dummy browser makes it easy to pick up the limbs on the screen or on the graphics and position it, or you can do that in entity browser. After that it comes dummy pre-simulation. Dummy pre-simulation can be done in dummy browser tool itself, where you have to right click on the dummy header and go to dummy pre-simulation, where you will define the required parameters for the simulation, and it is going to export the input deck with respect to any solver like Radios, LSDyna or PAMCrash. The next step would be seat deformer, where you want to remove the intersection between occupant and the foam of the seat. So there are two ways to do this. You can do it for the complete seat or you can deform just the foam. So when you are defining for the complete seat, you're going to export the input deck for the simulation and import the H3D in the same session to replace the nodal coordinates of the deformed parts. The foam deformation or foam compression happens within the HyperWorks. You have to select the solid components of the foam and dummy components, and it runs within the HyperWorks. The next tool is airbag folding tool. So if you are in Radios interface, it is going to allow you the airbag folding, and it is step-by-step process, and for each and every step it is going to write an out file or input deck file, and you just have to run that simulation and that will be input for your next step. So it starts with the creation of table, and then simple fold, then zigzag fold, roll, tab, and finally final step is fit the airbag into the canister or the housing. The next slide will take you through the short video or small video of how to access the occupant safety tools. So you can see if you go to safety tab here, click on it, it is going to show you occupant options. You click on the dummy, it is going to open the dummy browser along with the entity browser at the bottom, where you can move the limbs on the screen or in the entity browser. Similarly, if you click on the mechanism, it is going to open the mechanism browser along with the entity browser, where you can create the mechanism or modify the mechanism. For the seat deformer, if you click on the seat deformer, it is going to give you the options to select the parts and creating a input deck. There are two options in seat deformer. One is seat deformer and the foam deformer. If you click on the seatbelt icon, it is going to open the seatbelt browser where you can create the seatbelt and modify it. As you've seen in the previous slide, accessing the occupant tool is very easy and it's very intuitive, where user can easily define all the options. So this slide talks about the global overview of occupant safety tool in terms of intelligence, ease of use, and embedded automation. So this is embedded. This tool has all the kinematic solvers embedded within it. It supports multiple kinematic joints. It supports the stop angles for foot or the arm or any mechanism. It's ready to run the pre-simulation model. So when you do the pre-simulation for occupant, it is ready to go. When you export the pre-simulation deck, you just have to submit it. It is going to write everything, including control cards. And the metadata or the occupant tree or the dummy tree, mechanism tree, or the seatbelt tree, it's all going to write in the solver deck. So since this is browser based tool, it is very robust and you can directly access the features. It has advanced manipulator for interactive manipulation. So if you, for example, if you route the seat belt, you can modify the seat belt or interactively. And direct selection on graphics is possible. So when you are modifying some entity, you can directly pick it on the graphics and you can modify. HyperWorks offers auto positioning of dummy limbs and auto creation of mechanism. So as I said earlier, mechanism can be done automatically or manually. So when you choose the auto creation of mechanism, you just have to specify the body and the joint components, and it is going to create the mechanism. It can create the seat belt entities automatically. So for example, slip rings, retractor, pretensioner, and the 1D elements or the 2D elements, everything is automatic. And the seat belt update on dummy position change. So when you link the seat belt to the dummy, when the dummy moves, seat belt will automatically update its new position. Let's look at airbag solution, mainly airbag folding. So we are going to see the workflow and the process of folding the airbag. So when you are in radios profile, you are going to see this tab, airbag solution. And once you click on that airbag solution tab, you are going to see this ribbon menu. So all these steps are, this is step-by-step process, and it starts with creating the table, then simple fold, then roll it, tuck it, zigzag, flatten it, and then finally fit it into the housing, fit the airbag into the housing or the canister. So every step is automatic and it is going to write you input deck for that specific step. You have to run that step and use it as an input for the next step. So it is going to it's going to be automatic process, and since it is run by the solver, it is intersection free airbag, folded airbag. So this slide shows the process of airbag folding. So the first window shows simple fold. So this simulation is done and then you get that result for the flattening, and after the flattening you do rolling, and after that you have to fit that airbag into the housing or the canister. Let's move to safety regulation load case setup, and this tool allows user to position the barrier. So how you can access it is you just have to go to safety tab again. Along with occupant, you will see impacts here, impactors. And in those impactors, you have barrier positioner, you have pedestrian tool, and upper interior tool. So for the pedestrian impact, it is easy to position the head form and leg form for adult and child dummies. The pedestrian tool supports NCAPs and GTR safety regulations. Similarly, for IP impact, FMVSS 201 and ECE R21 are supported. For the barrier positioner, there are different barriers like side, front, pole are supported within HyperWorks. Moving on to next slide, which is pedestrian impact. So let's talk about pedestrian impact. This slide gives overview of the tool in terms of accuracy, improved user experience, and the performance. So pedestrian safety tool can be accessed through safety tool tab and just select the pedestrian ribbon in HyperWorks that I showed you in the last slide. It supports all the relevant regulations such as GTR 9, European Phase 2, Euro NCAP, and Chinese NCAP, etc. It also supports inclined ground. And to control the impact points, it creates the construction lines and the tapes. The pedestrian tool gives high accuracy. It maintains the precision or repeatability of the marking test zones and points for all the impact load cases and for all the vehicle classes. This pedestrian tool can mark up to full vehicle in few seconds. Also, it can export the impactor positioning in the solver deck for all the impact locations in few minutes. It also implements the impact points or the entity for ease of selection and visualization, as you can see in this picture. So we can conclude this way: the pedestrian to impact tool automates the vehicle marking, impactors positioning, and it exports the solver deck with minimal inputs. Therefore, it reduces the full process time or the lead time. Moving on to barrier positioning tool. So when the user is using barrier positioner tool, it automatically gets the impact barrier into the position based on the selected crash regulation. So this slide gives overview of barrier positioner tool in terms of reliability, user experience, and the performances. So in reliability, you can say automatic barrier positioning is based on the regulation or protocol. So barrier will be automatically positioned as per the regulation or the protocol. And different methods of positioning are available within HyperWorks. It includes overlapping method, side with IRD method, side with R point method, and pole impact. Also, there is option for user to define the gap between the barrier and the vehicle. It has a dedicated workflow with limited user inputs. So there are very few clicks user have to do just to get the position of the barrier or get the barrier into the position. So when user is defining those rotations or transformations within HyperWorks, it will write transform card automatically in the solver deck. So if user is using LS Dyna profile, it is going to write include transform card for LS Dyna deck. And if the user is using Radios profile, it is going to write the slash submodel deck. So it will be still an include file, but it will have the transform card defined within HyperWorks, or it will write the transform card for the respected solver. And when you are positioning the barrier in HyperWorks, it's very quick, and you can position the barrier within few clicks and few seconds. Moving on to safety regulations post processing. So it uses safety tools and Altair Safety Report Manager, which is ASRM. It supports multiple load cases such as MPDB, IP impact, pedestrian impact, side load cases, front load cases, and along with these load cases, it is going to show you the run statistics. It gives you the vehicle structural analysis as well, and if occupant is involved, it is going to show you the occupant numbers and the injury criteria. Moving on to safety regulations post processing. So it uses safety tools and Altair Safety Report Manager, which is ASRM. It supports multiple load cases such as MPDB, IP impact, pedestrian impact, side load cases, front load cases, and along with these load cases, it is going to show you the run statistics. It gives you the vehicle structural analysis as well, and if occupant is involved, it is going to show you the occupant numbers and the injury criteria, and it is going to export everything in the form of star rating or the failure criterias. So for let's say for example for side impact load cases, it will show you the intrusion in the survivable space along with the dummy injuries, and later on this is all kept in the Excel format. So basically when you run everything within Altair Safety Report Manager, it is going to show you everything in the form of star rating or the injury criterias. It is going to show you the intrusions as I said earlier and the global statistics of the simulation in the form of, let's say, energies or mass change and etc. So this was episode 1 of this HyperWorks Safety Tools series, and today to are just a global overview of pre and post processing solutions. There are two sessions coming up, episode 2 and episode 3. Episode 2 is dummy positioner and seat deformer, which is going to happen on July 5th. Episode 3 is seat mechanism, which will take place on July 12th. And stay tuned for after summer break sessions, which are 4, 5, 6, 7, 8, and 9. They are seatbelt tool, pedestrian tool impact, interior head impact tool, barrier positioner, safety report manager, and last, airbag folding. So that's all from me now. I'm open to any question that you have. Thank you very much.